In this video, we will learn about sets in C++. Sets are another type of container in the C++ standard template library. A set is great for when we want to work with sorted, unique data. Items in a set will always be sorted regardless of the order that they are added to the set in. Also, a set cannot contain duplicates, so if we try to add a duplicate element to a set, it will not get added, and only one of that element will remain in the set. To begin working with sets in C++, we need to include the set header file at the top of our code. Let's create a set of ints named integers. Next, we are going to add some elements to the set. To add elements to a set, we can use the insert function. Let's insert the values 20, 30, 15, and 0 to our integers set. Then we will use a for loop to iterate over each integer I in our integers set. Inside of the for loop, we will output I to the console, and then a new line. When we run the code, notice that the elements in our set were output to the console. If we want to order the numbers in a set in descending order, we can use the following syntax when declaring our integers set. We put a comma after int, and then we will add the word greater with int inside of angular brackets. It is important to note here that there needs to be a space between the two closing angular brackets, or you will get a compile time error. When we run the code, notice that the elements in the set were output in descending order. Sets cannot contain duplicates. For example, if we try to insert another 30 into the set, and then run the code, notice that the set only contains one instance of the element 30. This is because sets will not allow duplicates. The find function will give us an iterator to the element in the set if it finds it, else it will return a pointer to one past the last element in the set, the end pointer. First, let's create an iterator for a set of integers named it, that we set to a call to integers.find and pass in 20. Then we will have a for loop starting at it, running while it is not equal to integers.end, and incrementing it by 1 each time. Inside of the for loop, we will output asterisk it, and then a new line to the console. When we run the code, notice that 20, 15, and 0 were output. In this video, we will learn about maps in C++. Maps are containers that store elements associatively in key-value pairs. If you've worked with languages like C# or Python, a map is very similar to a dictionary in those languages. The first step to working with maps using C++ code is to include the map header file at the top of the code. Let's create a map that stores keys as strings and values as integers, named example. To insert key-value pairs into a map, we can use the insert function. Let's call the insert function to insert a pair with a key of the string 1 and the integer value 1 to our map. Then we will insert another pair with the key of the string 2 and an int value of 2, and another key value pair with a key of the string 3 and the int value 3. Let's learn another way to add key value pairs to a map in C++. First, we will create another map of strings to ints named example2. Then we will type example2, then square brackets, the string value 1, and set it equal to the int 1. This is how we would add the key with a string value of 1 mapped to an int value of 1. Next, we will add the key value pair 2, 2 to the map, and then 3, 3 to the map. We can access a value by referencing the key inside of square brackets. For example, we can output the value that corresponds to the string 1 in our example2 map. When we run the code, notice that the integer value 1 was output to the console. To remove all of the key value pairs from a map, we can use the clear function. For example, let's call the clear function on our example2 map. Then we will output if the map is empty by utilizing the empty function. When we run the code, notice that the empty function returned a value of 1, meaning true. In this video, we will learn about stacks in C++. Stacks are a container type provided by the STL. A stack follows the principle of LIFO. Last in, first out. The last element added to the stack is at the top of the stack. To begin working with stacks, we can include the stack header file at the top of the code. Inside of C++'s main function, we will declare a stack of integers named s. To add elements to a stack, we can use the push function. For example, let's push the values 1, 2, and 3 onto the stack using the push method. The top method allows us to look at the top value on the stack. We will output the string top and then the value of s.top to the console. To remove the top element from the stack, we can use the pop function. Let's call s.pop and then output the top value to the console. To obtain the size of the stack, we can use the size method. Let's output the size of the stack to the console. In this video, we will learn about working with queues in C++. Queues follow the principle of FIFO, first in, first out, meaning the first element added to the queue gets added to the front of the queue, and the subsequent elements you add get added to the end. Think of a queue as a line at a store. The customers are helped in the order they got on the line. To begin working with queues, the first step is to include the queue header file at the top of the code. Inside of C++'s main function, we will declare a queue of integers named queue. To add elements to the queue, we can use the push function. Let's push the elements 1, 2, and 3 onto the queue. Let's output the front element of the queue to the console. To retrieve the front element of the queue, we can use the front function. When we run the code, notice that 1 was printed to the console, since it was the first element added to the queue, and queues follow the principle of FIFO, first in, first out. Next, let's output the back element to the console using the back function. When we run the code, notice that 3 was output to the console. After that, let's output the size of the queue to the console. To do this, we can use the size function. When we run the code, notice that 3 was output to the console, which makes sense since our queue contains the elements 1, 2, and 3. To remove the front element from the queue, we can use the pop function. Let's call queue.pop. Then we will output the front element of the queue to the console. When we run the code, notice that 2 was output since 1 was removed when we called the pop function. Let's output the size of the queue to the console using the size function. When we run the code, notice that 2 was output to the console, which makes sense since the queue contains the elements 2 and 3.